Okay, hello people watching this video. This is 2-4. We did absolute values yesterday. We're going to do radicals today. Only 3 examples, and I switch example 5. We'll get to that. I'm going to change him just a little bit because I don't give you anything that's quite that ugly as a part of your homework. So we'll just do one of those. I'm going to change the homework assignment a little bit also, so take note of this. The people who are in here should already have maybe this written down, but instead of going 4 through 64, we're going to go 4 through 40 by 4s, okay? So you have a little less problems to do, and then I do want you to do 64, though, and 70, okay? So that's the change in the homework assignment. Get that written down, 4 through 40 by 4s. If you don't watch this video and you do all the way through 64, I won't feel bad for you, right? Okay. All right, so change that. We are on the back side of the notes. Here we go. We are doing square roots and solving for square roots, okay? These are also called radical equations. A radical symbol is that square root thing, and we're just solving for x like we would normally. Don't. Okay? All right, so we're solving for x, and we've got to figure out ways to do it. I'm going to go to example 5 first, because this one's a little bit easier than example 4. So write this guy down. I'm going to change example 5, and write this down. You people who are in here, change example 5, write this one down instead. The cubic root of 5 minus 11x, you need to write this down, equals 3, because I'm changing this problem. Write it down, write it down. We're going to solve it. This one's not too bad to solve. It's not a very good answer, but, you know, whatever. It's fine. Okay? Good? Ready? All right, we got to solve this thing. The first thing that you need to do is isolate the radical, which means get the radical by itself. So like the square root that I have here, he needs to be by himself on one side of the equal sign. Otherwise, this does not work. This one is by itself on one side of the equal sign, so we're ready to go. How do I get rid of a cubic root? Take it to the third power. Like a square root, I would square it, right? I'm going to take a cubic root. I'm going to take it to the third power because those cancel each other off. But if I take the left side cubed, I have to cube the right side also, right? Okay. So when I do that, 5 minus 11x is just going to fall out of there. What is 3 to the third power? 3 times 3 times 3. 27. Yeah. Okay. And then I just solve from there. All right. So, hey, this does come out nicely, actually.
No, it doesn't.
Yes, it does. Come on, boy. What are you going to move? Minus a 5 over minus a 5. So negative 11 equals 22, right? Okay. Then divide by negative 11. Divide negative 11. So x equals negative 2. Negative 2. Okay. Okay. Good. Happy with that? Not too bad. That was like fairly easy, right? What?
Can we do the 2x minus 3 minus x?
No. Nope, we're not going to do that one because I'm not going to give you one that hard on your homework assignment.
It's easy.
No, you can't just get rid of the square roots because there's a minus sign in between them. So it is not that easy.
Can you
tell us how to do it though?
So like what this would involve, I'm not going to go through it because it takes like oodles and oodles of time to do. But what this would involve is, okay, here you go. If we square that, right? If we square that, here's what will happen. This is like one term minus another term. So I would literally have to FOIL out the square root of 2x minus 3 minus the square root of x plus 7 times the square root of 2x minus 3 minus the square root of x plus 7, right? Which is nice because like these two, when I multiply those together, that's just 2x minus 3, right? Like that falls out of there, right? But when I multiply this by this, I'll still have a square root in there. So this will be like plus the square root of those two things multiplied together, right? And I'll have 2 of those, right? Oh, but it'll be minus. It'll be minus, yeah. It'll be minus 2 of those, okay? If you're watching this, don't write this down. Minus 2 of those. 2 of those, whatever. And then you'll have plus x plus 7, right? Yeah?
What would that middle piece be though?
It would be like, I'm just going to write it as 2x plus 3, or 2x minus 3 times x plus 7. Like that thing, right? Okay? Then you would eventually have equal to 2, right? Mm-hmm. So the next step, I'm going to stop after this, but the next step would be to move these all over to this side and then divide by negative 2, and then I would have to square that whole thing again.
And then would you move those over then?
Yeah, then you would have to like FOIL these out and move everything together and solve it, and yeah.
That does not sound hard.
I mean, it's not, I mean, like, it's, you're just going through the steps, but it's a lot of steps to do that, because you have to square it twice, right? And FOIL and do all that nasty stuff, so I don't give you anything quite that hard on maybe I'll just do that for like a bonus question on a test or something, I don't know. Anyway. But yeah, so like I'm not going to give you something like that. I will give you something that's this ugly. This is a little bit uglier, but not unmanageable, right? Okay, so we're going to solve this thing, and the key here is that we have to isolate the radical. We've got to get the radical by itself. So we have to move the 5, right? I need to get the 5 gone before I can even start. I've got the square root of 3x minus 11, and how do you want to write the right side? X minus 5. Okay, now, here is the tricky part. I got to get rid of the square root, so I'm going to square, right? Square and square, but the problem is I have to square x minus 5, and that is not the same thing as like x squared minus 25, right? Do we understand that x minus 5 squared is not x squared minus 25? X minus 5 squared is x minus 5 times x minus 5, and you have to FOIL it, right?
X
Like,
squared minus 10x minus 10x.
Right. So those of you, some of you can add that middle 2 pieces in your head, and I encourage you to do that if you can. X times x is x squared. X times negative 5 is minus 5x, and then we have another minus 5x, and then we have negative 5 times negative 5, which is plus 25. So if you are one of those people who can add those 2 middle pieces together, go for it. That's really good. X squared minus 10x plus 25. It's basically like saying negative 5 times negative 5 gives me this number, but negative 5 minus 5 will give me this number. Kind of like the reverse factoring, right? Okay, so that's what we're going to have on the right side. Good? Boys, stop.
Would you just add the...
Okay, and then 3x minus 11 is out of that square right there. Stop it. Stop it. I don't care. I'm looking at you like, don't throw it back. Put it up there. Put it up. Okay. All right, here we go. Next. Now what?
Move it all over.
Move it all over. I'm going to move these guys over here. So I'm going to minus the 3x from the 10, and I'm going to add the 11 to the 25, right? And then over here will be 0. Okay, so let's do that. 0 equals x squared minus 13x plus 36. Okay, pretty please. Is there 2 things that I can multiply together that give me positive 36, but when I add them give me negative 13?
X minus 9, x minus 4.
Yes, perfect. I love it.
You hear that? I'm perfect.
You're not perfect, but that is perfect. All right, x minus 9, x minus 4. Okay, so x equals 9, x equals 4, and those are my 2 answers to this problem. Yeah? So that one wasn't too bad, but the foiling, like, make sure you remember that you still have to foil at that side. I do give you maybe like 1 or 2 like that on the homework assignment, okay? That's like number 40 maybe, and maybe 36. No, this isn't number 40, but like it's like number 40, right? Good? Happy with that? Okay, last thing. One more. Example 7. We're not gonna do example 6. We're gonna do example 7. This is another type of a thing. So this is like the third category of other types of equations that we're going to have. So we did absolute value, we did radicals. They call it fractional equations. That sounds stupid. These are not they are fractional equations, but more specifically, they're called rational equations. That is the technical term for it. Rational equations, okay? A rational, Q-U-A-T-I-O-N. Rational equations are things that have fractions. So you have x's on the top and the bottom, okay? Now, I'm not just saying like fractions in general. They have to have like variables in the top and the bottom. So like if I have like y equals 1/2 x, that's obviously not a rational equation because the 1/2, yes, that's a fraction, but it's not x in the top and the bottom. This is actually linear, right? Okay, so just because you have a fraction doesn't mean it's a rational function. It has to have x in the top and the bottom in order to be rational. Make sense? Okay, yes, what is your question?
Okay, how do you pronounce R-A-T-I-O?
Ratio?
What?
Ratio? Like that?
Yeah, ratio. How do you pronounce
This
it?
is Egbers calls it a ratio.
Ratio.
It would drive me.
Ratio.
Ratio.
You know, whatever.
The
It's fine.
ratio.
The ratio.
Actually makes more sense.
Whatever.
Ratio.
All right. So now we've got to solve this thing. We're solving for x. What do we do?
Oh, multiply all letters and solve zero.
Yeah, we love this. Multiply. Yep. Multiply all this junk from the bottom. 2x squared plus 9x minus 5. I multiply him over to get him gone, right? Multiply by 2x squared plus 9x. And if you don't want to write all this work down, you don't have to, because 0 times that is just 0. So really the bottom just drops out, and that will always happen, that bottom just falls out as long as this number over here is 0. If it's not 0, if it's like a number like 1, it doesn't just go away, right? Okay, which is unfortunate. So hopefully that's 0 always. And then we do what? Like, what is this thing? Somebody said it. It's a complex trinomial. All right, so let's try and see. Sometimes it's not a complex trinomial, like it doesn't end up factoring down. I think this one does, though. So let's try. We take 6 times -1, which is -6, yeah? Okay. Multiply to get -6, add to get -1, which is that number there?
3 and 2.
-3, +2. Okay, so let's try it. So I break this down into the 4 pieces. 6x squared stays, -1 stays, and then would you like the 3 first or the 2 first?
Minus 3x plus 2x.
-3x plus 2x? Sure, let's try it. Let's see if that works. I think it does. Group. Okay, if I group the first one, what comes out? 3x. Left over is? I really hope it's 2x minus 1. Okay, what comes out of the second piece?
1.
Yeah, nothing, but you have to pull something out, which is a +1. If you can't pull anything else out, you have to pull a +1 out, and 2x minus 1. So I know I did it right because these two match each other, and my two groups are 2x minus 1 and 3x plus 1. Yep, 3x plus 1. Okay, then I set them equal to 0. Are we going too fast? Are we doing okay?
No.
Okay, equals 0. So 2x minus 1 equals 0. Can you do that in your head?
X equals
Add the 1, divide by 2, right? X equals 1/2. Okay, this one, 3x plus 1 equals 0. You would subtract the 1, divide by 3, so x is
-1/3.
-1/3, right? Subtract the 1, divide by 3, -1/3. Those are my two answers that I have for this fractionally thing, right? Yes? Yes? Good? All right, perfect. So when you have things like that, that's what, that's the third, this is like number 3, the third different type of other equation that you will have, okay? Good? All right, so make sure you have adjusted that homework assignment. You have less problems to do. That should shorten it up a lot bit, actually, a lot. And there you go, okay? Tomorrow.
Can we do it on Friday?
Tomorrow is Thursday, boy.
Yeah, can we do it?
And we're going to stretch it out that long? I don't think so.
A 4-day lesson.
I don't think so.